National Electrical Code Section 210.19a addresses branch circuits supplying lighting fixtures. The code states that branch circuits supplying lighting fixtures must have a rating not less than the combined load of the luminaires connected. This means the circuit's capacity needs to be adequate for all the lights and fixtures it powers. In the situation presented, the total load on the branch circuit is 1.5 amps. National Electrical Code Section 210.19 provides an allowance for using number 14 American wire gauge wire on a 20 amps branch circuit. This section states that branch circuits with a rating of 20 amps are permitted to supply receptacle outlets in addition to lighting outlets. This allowance permits the use of a number 14 American wire gauge whip to connect the bathroom exhaust fan to the branch circuit, given the total load in the circuit does not exceed 20 amps. It's crucial to understand that while the code allows for this specific situation, the entire circuit must still adhere to the overall load limitations. The 20 amp circuit breaker protects the wiring from overcurrent. Ensuring the total load remains under 20 amps is paramount for safety and code compliance. This includes all lighting receptacles and any other devices connected to the circuit. The exception for number 14 American wire gauge wire typically applies to short lengths such as the whip connecting the exhaust fan. The main branch circuit wiring is number 12 American wire gauge, which is appropriately sized for a 20 amp circuit. The primary concern is to prevent overheating of the conductors. Overloading a circuit can cause the wires to heat up, potentially leading to insulation damage and fire hazards. The circuit breaker is designed to trip and interrupt the current flow if the circuit is overloaded. This protects the wiring and connected devices. While the code allows for the number 14 American wire gauge whip in this scenario, always consider best practices for electrical wiring. Using the appropriately sized wire for the entire circuit provides an additional safety margin. If there is any doubt about the circuit's capacity or wiring, consult with a qualified electrician. An electrician can assess the situation and ensure the wiring meets code requirements. The National Electrical Code is a comprehensive set of standards for electrical installations. It is updated regularly to reflect new technologies and safety practices. Familiarity with the NEC is essential for anyone working with electrical systems. This includes homeowners, electricians, and contractors. Compliance with the NEC helps ensure the safety of electrical installations and reduces the risk of electrical hazard. When working on electrical circuits, always follow safe work practices. This includes turning off the power to the circuit before working on it. Use appropriate personal protective equipment, such as safety glasses and insulated gloves. If you are not comfortable working with electricity, hire a qualified electrician. Electrical work can be dangerous if not performed correctly. The National Electrical Code provides specific requirements for wire sizing based on the circuit's ampacity. Ampacity refers to the maximum current a conductor can carry without exceeding its temperature rating. Number 12 American wire gauge wire typically has an ampacity of 20 amps, while number 14 American wire gauge wire has an ampacity of 15 amps. The code allows for the use of number 14 American wire gauge wire on a 20 amp circuit under certain conditions, such as the whip described in the question. However, it is important to ensure the overcurrent protection device, the circuit breaker, is appropriately sized for the wire gauge. In this case, a 20 amp circuit breaker is used to protect the number 12 American wire gauge wiring of the main branch circuit. The number 14 American wire gauge whip is protected by the same 20 amp circuit breaker, which is permissible under the exception mentioned earlier. It is important to note that some local jurisdictions may have additional requirements or restrictions on electrical wiring. Always check with the local authorities to ensure compliance with all applicable codes and regulations. Electrical inspections are typically required for new installations and modifications to existing electrical systems. These inspections help ensure the work is performed safely and meets code requirements. When planning an electrical project, it is always a good idea to consult with a qualified electrician or electrical inspector. They can provide guidance on code requirements and best practices. Electrical safety is paramount, and following the NEC and local codes helps minimize the risk of electrical hazards. In summary, the National Electrical Code allows for the use of a number 14 American wire gauge whip on a 20 amps branch circuit under specific conditions, such as when connecting a bathroom exhaust fan. However, the total load on the circuit must not exceed 20 amps, and the overcurrent protection device must be appropriately sized. Always follow safe work practices and consult with a qualified electrician if you have any questions or concerns. Always ensure all electrical work complies with the National Electrical Code and local regulations to ensure safety and prevent electrical hazards. Understanding the specific allowances and restrictions in the NEC is critical for safe and compliant electrical installations. Always prioritize safety and consult with qualified professionals when necessary. Firstly, ensure the total load on the circuit does not exceed the rated capacity of the wiring and overcurrent protection device. Secondly, use appropriately sized wiring for the main branch circuit to handle the anticipated load. Thirdly, follow all applicable codes and regulations to ensure compliance and safety. One should consider the voltage drop in the circuit, especially for longer runs. Excessive voltage drop can affect the performance of electrical equipment and may require using a larger wire gauge. 2. Ensure all connections are made properly and are secure. Loose connections can cause overheating and electrical hazards. 3. Label all circuits clearly to facilitate future maintenance and troubleshooting. This helps prevent accidental disconnection of critical circuits. The NEC also addresses grounding and bonding requirements. Proper grounding and bonding help protect against electrical shock and reduce the risk of fire. Grounding provides a path for fault current to flow back to the source, causing the overcurrent protection device to trip. Bonding ensures all metal parts of the electrical system are at the same potential, reducing the risk of shock. When working with electrical systems, always use appropriate testing equipment to verify the circuit is de-energized before working on it. This includes using a voltage tester to confirm the absence of voltage. Double-check the readings to ensure accuracy. Never assume a circuit is de-energized without verifying it with a reliable testing device. If you encounter any damaged or deteriorated wiring, replace it immediately. Damaged wiring can pose a serious electrical hazard. Always use approved wiring methods and materials for electrical installations. This includes using the correct type of conduit and fittings. Avoid using substandard or unapproved materials, as they may not meet safety standards. The NEC also addresses the installation of electrical equipment in wet or damp locations. Special precautions are required to protect against moisture and corrosion. Use appropriate enclosures and fittings that are rated for wet locations. When installing lighting fixtures, follow the manufacturer's instructions and the NEC requirements. Ensure the fixtures are properly grounded and supported. Do not overload lighting fixtures or use lamps with a higher wattage than the fixture is rated for. Always inspect electrical equipment regularly for signs of damage or wear. This includes checking for cracked or frayed wiring, loose connections, and damaged components. Repair or replace any damaged equipment promptly. The NEC provides guidelines for the installation of smoke detectors. Smoke detectors are essential for early detection of fire and can save lives. Install smoke detectors in accordance with the NEC and the manufacturer's instructions. Test smoke detectors regularly to ensure they are functioning properly. Replace the batteries in smoke detectors at least once a year. The NEC also addresses the installation of ground fault circuit interrupters or GFCIs. GFCIs are designed to protect against electrical shock in wet or damp locations such as bathrooms and kitchens. GFCIs detect ground faults and interrupt the current flow, preventing electrical shock. Install GFCIs in accordance with the NEC requirements. Test GFCIs monthly to ensure they are functioning properly. When using extension cords, use cords that are rated for the intended use. Do not overload extension cords or run them under rugs or furniture. Inspect extension cords regularly for signs of damage or wear. The NEC provides guidelines for the use of surge protection devices or SPD. SPD are designed to protect against voltage surges, which can damage electronic equipment. Install SPD in accordance with the NEC requirements. Surge protection is especially important for sensitive electronic equipment, such as computers and televisions. When working on electrical systems, always maintain a clean and organized work area. This helps prevent accidents and makes it easier to find tools and materials. Do not leave tools or materials lying around where they could be a tripping hazard. Always clean up any spills or messes promptly. The NEC is a complex and comprehensive document. It is essential to stay up to date on the latest revisions and interpretations. Attend electrical training courses and seminars to enhance your knowledge and skills. Join professional organizations such as the International Association of Electrical Inspectors or IE to network with other professionals and stay informed about industry trends. The NEC is not intended to be a design manual. It provides minimum safety standards for electrical installations. Always consult with a qualified electrical engineer for complex electrical designs. Electrical design requires specialized knowledge and expertise. Do not attempt to design an electrical system unless you are properly trained and qualified. The NEC is a living document that is constantly evolving to meet the changing needs of the electrical industry. It is important to stay informed about the latest changes and updates to the code. Subscribe to electrical trade publications and attend industry events to stay current on the latest developments. The NEC is a valuable resource for anyone working with electrical systems. Use it as a guide to ensure safe and compliant electrical installations. Always prioritize safety and consult with qualified professionals when necessary. Remember, electrical work can be dangerous if not performed correctly. Always take the necessary precautions and follow the NEC requirements to prevent electrical hazards. Stay informed, stay safe, and continue to learn about electrical safety and the National Electrical Code. Always refer to the latest edition of the National Electrical Code for the most current and accurate information. The NEC is available for purchase from various sources, including the National Fire Protection Association or NFPA. Consider purchasing a copy of the NEC and keeping it readily available for reference. The NEC is a valuable tool for ensuring electrical safety and compliance. Always use it as a guide and consult with qualified professionals when necessary. Remember, electrical safety is everyone's responsibility. By following the NEC and safe work practices, we can all help prevent electrical hazards and protect lives. It is crucial to consider the ambient temperature when determining wire ampacity. Higher ambient temperatures can reduce the ampacity of conductors. The NEC provides ampacity correction factors for different ambient temperatures. Apply these correction factors when necessary to ensure the wiring is properly sized for the operating conditions. Also, consider the number of current carrying conductors in a raceway or cable. When multiple current carrying conductors are installed together, their ampacity may need to be derated. The NEC provides derating factors for different numbers of conductors. Apply these derating factors when necessary to ensure the wiring is properly sized for the operating conditions. Always use the correct type of wire for the intended application. Different types of wire are designed for different environments and conditions. Use wire that is listed and labeled for the intended use. Do not use wire that is damaged or deteriorated. Always inspect wire before installation and replace any damaged wire. When making connections, use the correct type of connector for the wire and the application. Ensure the connections are tight and secure. Loose connections can cause overheating and electrical hazards. Do not over-tighten connectors as this can damage the wire. Use a torque wrench to ensure connectors are tightened to the proper torque. When installing wiring in conduit, use the correct size of conduit for the number of wires. Do not overcrowd conduit as this can damage the wires. Use a wire lubricant to make it easier to pull wires through conduit. When installing wiring in cable trays, use the correct type of cable tray for the application. Ensure the cable tray is properly supported. Do not overload cable trays as this can damage the cables. Always follow the manufacturer's instructions for installing wiring and electrical equipment. The manufacturer's instructions provide important information about the proper installation and use of the equipment. Ignoring the manufacturer's instructions can void the warranty and create safety hazards. When working on electrical systems, always be aware of your surroundings. Watch out for overhead power lines and other hazards. Do not work on electrical systems in wet or damp conditions. Use appropriate personal protective equipment, such as safety glasses, gloves, and footwear. Never work alone on electrical systems. Always have someone nearby who can assist you in case of an emergency. Know the location of the nearest emergency shut-off switch. If you encounter an electrical emergency, shut off the power immediately and call for help. Always report any electrical hazards to the appropriate authorities. By following these safety tips, you can help prevent electrical accidents and protect yourself and others from harm. Remember, electrical safety is everyone's responsibility.